To continue with this presentation, I will be covering three topics. The first one will be new challenges in wireless and free space optimal communications. The second one will be multiple input and multiple output systems and its benefits in the industry. And the third one will be how MIMO systems are designed and how they could impact different applications for different sectors. In this case, I will discuss the smart grid communication network. By using the standards for frequency allocation published by three different standard bodies, the International Telecommunication Union, European Conference of Postal and Telecommunications Administrations, the Inter-American Telecommunication Commission, and some information from NASA, we could determine that the main applications with the allocated wavelengths and the frequencies of major electromagnetic waves clearly shows that the spectrum is very congested and that there exists no room for new applications and services. As a side note, I would like to mention that only for SMS, which is a relatively new application for mobile phones, we have been able to generate benefits around 110 billion US dollars a year worldwide. This fact proves that the communication market is massive. According to the Independent, a UK newspaper, on Tuesday 7 October 2014, there are officially more mobile devices than people in the world. The world is home to 7.2 billion gadgets, and they are multiplying 5 times faster than we are. Besides, customers become more exigent. Communication industries try to cope with the increasing number of customers and their high demand. This phenomenon is even without taking into consideration that many standard bodies are developing the fifth generation, which is commonly known as 5G. This generation should reach around 1 gigabytes per second, and it should be adapted to handle the Internet of Things, or IoT. The IoT is a major challenge for our communications networks. In fact, IoT will allow the communication among devices, which will be massively deployed in smart cars, smart roads, smart cities, and buildings. Also, it will be implemented for security and safety and industrial M2M communication. It is anticipated that in 2020 there will be around 50 billion connections according to Cisco. So 50 billion things will connect to the Internet of Everything in just a few years. The value this could create for service providers by 2022 is around 1.3 trillion US dollars, which presents the dilemma of the telecommunication industries, where the increasing of the customers' number will definitely impact the spectrum bands, which are already congested. A technology that promises enhancement in the achievable throughput and overall spectral efficiency is MIMO systems. The scarcity of the wireless spectrum is the main factor that hinders the vision for wireless access, everywhere, anytime, and perhaps the toughest challenge that wireless research has to undertake. Overcoming this challenge requires innovations in various areas, including novel ways for spectrum sensing and reuse. As discussed in previous sections, mechanisms for using higher frequencies, such as wave, and generally more efficient protocols and systems. MIMO systems are one of the most promising technical advances in wireless communications in recent years. Such systems facilitate high throughput transmission in various recent standards, including LTE, WiMAX, WINR, among others. Space modulation techniques as space shift keying and spatial modulation are MIMO methods that use the multiple transmit antennas in an innovative fashion. Transmit antennas are considered as spatial constellation points and utilized to carry additional information bits to boost the overall spectral efficiency. Each antenna index is utilized to carry additional information bits and a special multiplexing gain of base 2 logarithm of the overall number of transmit antennas. Besides, Activating single transmit antenna at a time eliminates inter-channel interference, relaxes inter-antenna synchronization requirements, reduces receiver complexity while allowing the use of a single RF change at the transmitter. To study the impact on this technology, we analyzed several applications use cases like the one presented in this slide. It has been shown that space modulation techniques enhance error performance with a moderate number of transmit antennas as compared to other conventional MIMO techniques. In addition, it is demonstrated that these techniques are more robust to channel imperfections, such as spatial channel correlation and channel estimation errors, as compared to other MIMO techniques, since the probability of error of space modulation systems is not determined by the actual channel realization, rather by the differences between channels associated with the different transmit antennas. To continue this presentation, I will hand the ball over to my colleague Jose, who is going to discuss another MIMO use case application. In this case, 5G towards energy efficiency, low latency, and high reliable communication networks. Thanks.